Welcome to the trading floor. And when it comes to Cambridge IGCSE Physics, your exam is exactly that, a trading floor, where you are exchanging your time for marks. Every single minute is a split-second decision, and you need to invest your time where the mark yield is highest. I'm your host, and today we are building an unshakable mastery blueprint for syllabus 0625. Listen, if you ever sat in that exam hall feeling like you're just regurgitating memorized, disconnected facts and desperately hoping the examiner gives you the benefit of the doubt, this explainer is going to completely change your approach. We are officially abandoning rote memorization right now. Instead, we are engineering a powerful first principles system designed specifically for securing maximum marks. And we are starting with the absolute bedrock of physics, the system of units. Getting this fundamental microtopic right isn't just about adding a letter to the end of a number. It literally changes how you decode the entire syllabus, analyze data, and structure your high-value answers.
Here is our strategic roadmap for today's session. We're going to kick things off by exposing the physics exam trap that catches out over half the candidates. Then we'll pivot into concept-first thinking, followed by a breakdown of the 4 linked steps. After that, we look beyond the classroom to see how this applies to real data, unpack the incredibly effective DREA method for structuring your answers, and finally, lock it all in with quick recall prompts.
Let's move straight into Section 1, the physics exam trap. It's time to move far beyond isolated facts and look at what's actually happening on your exam papers. To understand the trap, we need to introduce 2 typical students. Let's call them Alex and Sam. When faced with a core physics question, Alex overloads the answer page with raw physics facts. Alex will write down every single equation they can remember about forces or energy, but completely fail to provide any physical analysis. There is zero connection to the system of units. On the other hand, we have Sam. Sam rushes. Sam reads the first half of the question, completely misses the specific command words like explain or deduce, and writes a one-line answer with the wrong units. Both Alex and Sam are falling into the exam trap. A strong top-tier approach always begins with this simple question. What physical effect, measurement, or prediction actually depends on understanding a system of units? By asking this, you make the concept absolutely necessary rather than just decorative knowledge. Units give a measurement its physical meaning. Without them, your predictions entirely fall apart, and the examiner gets out the red pen. Let's look at their flawed answers side by side. The contrast here is incredibly striking. On side A, we have Alex stuck in the rote trap, treating physics concepts like flashcards, totally dependent on memorized wording. When Cambridge examiners slightly twist the context of a question, rote memorizers like Alex absolutely freeze. They don't know how to adapt because they only know the textbook definition. On side B, we have the secure approach. This is where top students operate. They are able to reason through entirely unfamiliar questions by focusing purely on cause and effect. They look at the units, say joules per kilogram degree Celsius for specific heat capacity, and they can reconstruct the entire formula and physical meaning just from the units alone. You absolutely must shift from simply quoting disconnected processes to actively linking them to a physical effect.
That brings us to Section 2, concept-first thinking, which is the true vocabulary of physics. But before we continue and reveal exactly how to decode these command words, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's break down how top students actually structure their physics answers using concept-first thinking. You might have heard of the Peel framework in other subjects: point, evidence, explanation, link. Well, this is the physics equivalent. A truly effective, high-scoring explanation moves systematically. You shouldn't just dump dense algebra onto the page like Alex does. Instead, begin with a concrete, everyday example to ground your answer. From there, introduce formal language and physics vocabulary gradually, paying strict attention to your command words. Only when the setup is clear do you drop in that symbolic relationship or mathematical definition. And finally, you anchor it all by returning to a worked explanation that links back to the original question. This proves to the examiner that you understand the physics, not just the math. I'm going to give you 30 seconds to think about how you would apply this to a question about terminal velocity. Think about the concrete example first, then the vocabulary. This quote right here brilliantly illustrates the examiner's mindset. Whether you are sitting the 0625 paper, the 0651, 0652, 5054, or even gearing up for A-Level 9702, the mandate is exactly the same. If the topic involves fields, forces, particles, circuits, or waves, insist on cause and effect rather than isolated facts. The people marking your paper do not just want to see that you've swallowed a revision guide. They desperately want to see the underlying physics explained through a rigorous cause and effect chain. Why did the current drop? Because the resistance increased, which physically limited the flow of electrons through the lattice. Cause and effect. It is all about the why, tracked through the correct system of units.
Moving to section 3, the 4 linked steps. This is where we undergo the transformation and build your gateway to a bigger scientific pattern. Let's do a live rewrite of those flawed answers we talked about earlier. We are going to watch the red pen marks transform into green check marks using this physics success blueprint. Mastering these 4 linked steps is an absolute game changer for your grades. Step 1. Identify the quantity or phenomenon. Are we talking about kinematic energy? Be specific. Step 2. State the relationship involved. Write down the correct formula and define the units. Step 3. Explain the underlying physics using that cause and effect chain. Step 4. Connect it to an observation, experiment, or real device. If you write an answer using these 4 steps, you are hitting every single assessment objective Cambridge throws at you. You are showing deep theoretical understanding, flawless mathematical application, and real-world synthesis. Let's take 60 seconds right now for you to mentally rewrite a basic answer about density using these 4 steps. Go from rote memorization to a structured, unshakable answer. Now, welcome to Challenge 1 of our interactive workshop, the Data Scan. I want you to imagine a complex physics velocity time graph in front of you. You have 60 seconds. When you look at that data, you cannot just describe the geometry. If you write the line goes up, you get 0 marks. You must apply the physical interpretation. Look at the slope. What does the steepness physically represent? In this case, acceleration. Look at the area. What physical quantity is found under the curve? Total distance traveled. Look at the direction. How does it indicate a physical change, like reversing velocity? Look at the shape. Is it a curve? Then acceleration isn't constant. You have to extract the core trend and link the visual geometry directly back to the physical world and its specific units.
Section 4. Beyond the classroom, where the physics actually matters. But before we get into the real-world applications, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 3 great boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's look at this table and roll into Challenge 2 of our workshop. Find the flaw. I want you to look at these real-world applications. A common flawed exam paragraph might say, "Engineers use physics to make bridges safe." The examiner reads that and gives no marks. Why? Because there's no unit, no system, no specific physical linkage. To get the marks, you need to state how they use physics. They predict structural integrity by calculating stress in pascals and forces in newtons. In transport and safety, they don't just make cars crash better, they calculate kinetic energy in joules and deceleration to engineer crumple zones that increase impact time, thereby reducing the net force. From energy systems measuring transfer rates in watts to medical techs scaling microscopic devices, units are the foundational language. You must be able to name one real situation and explain exactly why the physics, measured in specific units, helps predict outcomes. Let's transition into Section 5, the DREA method. This is the safest, most reliable exam structure you will ever use. For Challenge 3, we are doing a speed writing exercise. But first, let's look at the weaknesses on side A. This is exactly what Sam does. Sam writes a correct formula, but doesn't explain the variables. Or Sam quotes a process without a physical link, or gives an example without justifying why it follows the physics. This bleeds marks. On side B, we have the safest method, systematically using definition, relationship, explanation, and application. I'm putting a 30-second timer on the clock right now. I want you to mentally draft a perfect paragraph about electrical resistance using this exact DREA method to build an unshakable answer. Go from the definition to the formula, explain the physics, and give a practical application. Time's up. Let's see if your answer matched the DREA framework. Think of this as the ultimate physics equivalent to the Peel framework used in humanities. It guarantees your answer has structural integrity. D stands for definition. You clearly state the key idea and its units. R is for relationship. You provide the governing equation or rule, like V equals IR. E is for explanation. This is the meat of your answer, where you detail that critical, logical cause and effect chain. If the temperature goes up, what happens to the particles? And finally, A is for application, providing a real-life practical use or a specific laboratory experiment. Using this 4-part framework acts as a checklist, guaranteeing you hit the exact mark scheme criteria the examiner is actively hunting for.
This is the final system. When you target actual Cambridge pass papers, the questions practically beg for this structure. We have 3 rules that guarantee top marks. Rule 1, command word decoding. If it says define, you give the key idea. Rule 2, the Peel or DREA framework application. Explain the physics using that clear cause and effect chain, describe an experiment or calculation, and justify it. Rule 3, the time management matrix. Don't spend 10 minutes on a 2-mark question. Look at the marks available. If it's a 4-mark question, the examiner wants all 4 elements of the DREA framework. The method precisely mirrors the anatomy of the exam itself, ensuring your time is invested exactly where the marks are.
We've reached Section 6, Quick Recall Prompts. It is time to test your absolute exam readiness.
Let's log in everything we've learned today into a mental cheat sheet recap graphic. Think of this as your progress bar reaching 100%. Whenever you're revising a new topic, force yourself to answer these 4 rapid-fire revision prompts. Number 1, what is the core idea? Number 2, what changes physically in the system? Number 3, what measurable quantity, specific unit, or graph shape actually shows this change? And number 4, where is it used in the real world? Notice how seamlessly these align with the DREBA method in everything we've discussed. If you can actively use these 4 prompts when studying any concept on the 0625 syllabus, your foundational knowledge will be bulletproof, allowing you to easily tackle the hardest extended response challenges.
So I will leave you with this final critical challenge. Can you answer those 4 prompts aloud right now for the topic of units? Take a second to test yourself, because once you can answer these aloud confidently, you have officially transformed raw, disorganized data into true Cambridge exam mastery. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.